Hello everyone, welcome back to Analyst Chronicles. So today we are diving into the world of machine learning with a classic dataset, the Titanic dataset. So we'll walk through a logistic regression model step by step, starting from pre-processing to model selection, and finally we will visualize our predictions. So let's get started. So I just wanted to explain few things about what is a logistic regression. I mean, when do we use this logistic regression? I have already covered in other videos, but since we are working on Titanic dataset with logistic regression, so I just wanted to give some glimpse about logistic regression, how it works. Logistic regression is a powerful statistical method used for binary classification problems. Binary classification problems means either we have only two categories like yes or no or true false. For example, in Titanic case, survived or not survived. And like we have to predict either one or two, only two categories. So when we wanted to work on this binary classification, and this logistic regression is the best model, machine learning model to use. So in this video, we will use it to predict whether a passenger on the Titanic survived or not. Our steps will include data pre-processing, feature selection, model training, and model evaluation. Pre-processing means so if I have any categorical data, I need to convert it into numerical data, because model will learn the patterns from the numerical data, so that the model will be trained and we will get a better accuracy. So if you do this pre-processing steps like normalization and also the converting categorical into numerical, all these things, and also we need to select the appropriate features, like which features are highly correlated among with a target variable, like how, I mean, what kind of passengers are survived based on the input features we have in this data set. And at last, we need to train the model, so by splitting the data into training and testing data set, so that the machine will be trained with the training data, and machine will be able to understand the patterns with the training data and will be able to predict by feeding the training data set. Then afterwards, I wanted to evaluate the model, how well the model was trained. So if I pass a new data set, how the machine is predicting with the input features. So without any further delay, let's jump into the video. So I'm importing all the necessary libraries like Pandas for data manipulation, and for model selection, I'm importing train test split. I just wanted to split the data into training and testing part. So that is why I imported train and test split. And also we are working on a binary classification. So this time I'm using logistic regression. So I have imported from sklearn linear model logistic regression. And in the later part of the video, I need to evaluate my model. So that is why from sklearn matrix, I'm importing accuracy score to check the accuracy of the model. And confusion matrix is like we need to see the type 1, type 2 errors, like true positive, true negative, false positive, false negative. And classification report will give us all the details about how the accuracy, precision, all these things. And I'm importing Seaborn and Matplotlib for to visualize the actual versus predicted values. So this is my dataset, a Titanic dataset. So pd dot read underscore CSV, since my file is in CSV format. So I just imported my dataset to the Jupyter notebook. So this is how my data set looks like. So my data set has a passenger ID, which is nothing but each and every passenger as a unique IDs, like a ticket number, something like that. And this is my target variable, whether that particular passenger is survived or not survived. So zero is being, I think zero is not survived, one being something, but it could be zero is nothing but not survived, one is being survived. So one is true and zero is false, something like that. And the class of the particular first class passenger, and the name of that the passenger and the gender, age. So we do have all this ticket price, fare, and the ticket number, cabin, where they are in the Titanic ship and embarked. So this is my data set. This is first 5 rows of the data set. And if I wanted to look at the data set in detailed, so my data set has 891 entries. So df.info will give me all the information about the data set, including all the columns. If there are any null values, we can able to see, and also the type of the column. So this is the name of the column. This is all the number of entries. And if there are any null values, it will show here. And this is the data type of the column. For example, so this is my target variable survived. It has 891. It doesn't have any null values because my total entries are 891. It is filled with all 891 entries, and this is in int. So it is a number 0 and 1. So that is why it's an int. So similarly for name also, we do not have any null values. It is an object because names are in a string format, so that is why it is showing as object. So we do not have null values in more columns, but whereas in age column we have a few null values, and also we have a lot of null values in cabin column. 204 entries are filled, and remaining 600 plus rows are empty, like not filled with anything. So we are gonna work on all these things in the next steps. So this is my data set. So now let's jump into the pre-processing of the data. So now I wanted to fill all the null values because my in age column I have few null values, and also in cabin column and embarked also we have very less. It is 890, 889 total, or 891. Just two values are missing. So that is why, so in handling the missing values, so it is very important to handle these missing values. We cannot just like that, we cannot drop it just like that, and we cannot fill it with any other things. So that, I mean, we need to be very careful while handling these missing values, because see, this will impact the model. When we are training the model, the data where we are filling, this will impact. So so that without disturbing the skewness of the data, so we need to fill the null values as per the requirement. So here my age column has around 200 plus null values. So I am using a median age. For example, age column has so here you can see age column has 22, 38, 26. So I'm taking median of all the ages, so that it will not much impact on my original data set as well as the skewness of the data. So that is why df.age.fill I'm filling the null values with age dot, sorry, df of age of median in place is equal to true, because I want to save these changes in my original data set. And also my embarked column, which is a categorical column, so that is why I'm using mode here. Mode is nothing but the more repeated category. Median is nothing but the mid value. So I'm replacing null values with the fill na df.embarked mode, and in place is equal to true. And I'm just dropping this cabin so that it doesn't affect anything. So cabin column, so that is why it has lot of null values, and also it doesn't impact anything. So that is why I'm dropping. So now I'm encoding categorical variables. Now I need to convert my categorical columns into numerical columns before splitting the data or before training the model. So this will convert. There are two ways. So we can convert with pandas, and also we can use one hot encoder. So we have two ways. Here I'm using pd.getDummies. It will convert. I need to select the columns, appropriate columns to convert. So here I have this sex or the gender column, which is updated with male and female. So I need to convert it, male being 1, female being 0, something like that, or female being 1, male being 0, something like that. So I need to convert it, and also I need to convert the embarked this classes. So it also has some categories. I need to convert these categories into numerical data. So that is what I did, pd.get dummies. And now dropping irrelevant features like name also. Name is doesn't affect anything because person name is does not impact whether the passenger is survived or not, so that is why I'm dropping. And also ticket number is also does not have any impact, and the passenger id also does not have any impact. That is reason why passenger id, name, and also the ticket number I'm dropping. Now next step is, so we are done with the pre-processing. Like wherever the null values are there, I'm gonna see I have filled with median, age column filled with median, so that it will not impact the skewness of the data, and embarked column filled with mode, and cabin is dropped because it doesn't has any impact on the survived or not survived. So that is about pre-processing of the data. Now I need to select the appropriate features. So feature engineering, this is a very important step in training any machine learning model. So I am taking all the columns like apart from survived, because this is my target variable. So that is why df dot drop survived and on axis is equal to 1, because I wanted to include all the necessary features. So whatever dropped here, it was target variable. That is why I added y is equal to df of survived. So I'm done with my feature selection. Now the next step is like splitting the data set into training and testing. So my machine will be trained with the training data, and after once we're done with the training, so machine has to predict with the testing data. So I'm importing this train test split from sklearn dot model selection. So I just feeded my input features, which is x, and my target variable y, and test says I'm giving 20%. So 0.2 is nothing but 20% I wanted to test. So 80% of the data I'm feeding to the machine to learn the patterns from the 80%, and remaining 20% later onwards I will feed it to the model once it got trained. So that machine will predict. So that is about splitting the data into training and testing. Now I need to train the model. So I'm importing logistic regression since it is a binary class classification problem. And so I'm importing sklearn dot linear model. From sklearn dot linear model, I'm importing logistic regression. So this is my model, logistic regression. So maximum iter I'm giving 200. And so this is what model dot fit, which will train the model. So I'm just feeding the training data sets of input features and output target variable y. So model has been trained. So now I need to evaluate the model, how well the model trained. So now I already imported all these things, accuracy score to look at the accuracy of the model, and confusion matrix to just to see the type 1, type 2 errors. So I now I'm just asking machine to predict with the testing data set. Machine has been trained. Now I need to test it. So model dot predict x test. Then machine has been predicted. It has been assigned to ypred. And accuracy. So accuracy is nothing but we can able to see how accurate machine is predicting. So accuracy is equal to accuracy score. So which was we imported from sklearn metrics. So I need to y test and y predictions. So the difference is not here the machine will sorry, the accuracy will be calculated from the testing and also the predictions. So this is my accuracy score and confusion matrix for a type 1, type 2 errors, and ROC curve. And if I wanted to plot false positive rate, true positive rate, receiver operating characteristics, all these things with ROC curve. So this is my true positive, true negative, false positive, false negative. Accuracy, I'm getting 81%. So, and this is my receiver operating characteristics, and you can see the ROC curve with the 80%. So true positive rate is high, true positive. This is true positive 90, and the false positive rate is 55. So that means the machine is trained very well, and we can see it with the uh, confusion matrix. So now I wanted to visualize what are all my actual values and what are all my predicted values, how well these are differ. So here I'm just importing a Seaborn. So this is my data set actual and being y-test predicted. I'm assigning it to I mean predicted values predicted. I mean renaming, and I just wanted to fill visualize the Seaborn. So here you can see so 0 and 1 predicted values, actual values. So here you can have a better idea of actual versus the predicted survival count. So this is how you can see the actual versus predicted, and this is a confusion matrix: true positive, true negative, false positive, false negative. So when we are getting true positive and false negative, that means the model is trained well. It is giving me accurate results. So that is about this famous Titanic dataset, which is a very simple dataset to understand, and also uh, the columns also we can able to understand what are all the categories there in the data set, and which feature is for which type of category we can able to understand. This is very easy data set to train a binary classification problems. If I wanted to practice a logistic regression model, this Titanic data set is the suitable option. So that is what we have covered so far. So I hope it is a very good data set to work on logistic regression. So if you guys have any further questions, please feel free to comment on the video. If you really like the entire video, please click on the like button. If you really enjoying the all other videos along with this Titanic dataset video, so please subscribe the channel. So the training the model is very simple. We will have the same steps in all the other algorithms, but the main important thing is like the data pre-processing and also the feature engineering. You need to select the appropriate features to which are all impacting the output. You need to see the correlation. You need to check a lot of things before building a model. So pre-processing feature selection is a very important part, and also the selecting the appropriate machine learning model. So thanks everyone. See you in another video. Bye.